morning, student. In the previous class, we have covered the topic that is laws of motion, which is given by the scientist Isaac Newton. And these laws are used to discuss the or to study the motion of different objects. As we are having three laws, that is the first law of motion, which states that every object that which is at rest, that remains at rest, and if the object is in motion, that remains in motion until or unless an external unbalanced force is applied. After that, we are having the second law of motion, which states that force is directly proportional to mass and force is directly proportional to acceleration. Acceleration means the change in speed with time. And the third law is the third law of motion, that is, for every action there is equal and opposite reaction. So students, so today we will discuss the factors which are associated with the magnitude of force, and force has both magnitude and direction. Now the first topic is the factors associated with magnitude of force. Now here the word magnitude is there. Now whenever you will see this word magnitude means that is how much amount, means a numerical value. Magnitude means the numerical value. For example, I have considered here 1 Newton. So here 1 is the magnitude of force. So here we have to find, that is, what are the different factors which associated with the magnitude of force. So for this, let us consider example. I have considered two bodies which are having the same mass, let it is of 1 kg, and I have already told you that unit of force is Newton. Suppose we have applied a force of 1 Newton on the first body and 2 Newton on the second body. Then what will happen? The object on which we are applying the force of 1 Newton, that will attain a less speed, and the object on which we are applying the more force, that will attain the more speed. It means that is, in the body 1 there is less change in the speed, and in the second body there is more change in the speed. So what is the first factor which is associated with the magnitude of force? That is the change in the value of speed. That is, simply you can say that is a change in speed. Now second example, for example, now this is the first, we are having the first factor which is associated with the magnitude of force. Now to find out the second, let us consider an example. I have considered two bodies of different masses. For example, you can consider the light body, that may be a cycle, and the second body, that may be a truck. Now we are applying the same force on these two. So this body is having less mass, this body is having more mass. So we are able to displace the body of less mass by this much of force, but this 5 kg mass is hardly move, or it will move from a very small distance from its place. So what is the conclusion of this? That is, more force is needed to move the heavy objects. So what is the second factor which is associated with the magnitude of applied force? That is the mass. So what are the two factors which are associated with magnitude of force? They are change in speed, and number 2 is mass. Now let us understand this example with the help of one activity. Here I have considered two coins of same mass. Now if I will apply less force, now I am going to apply the force on these two. I have applied a force on this coin, and in the second coin I am going to apply less force. So you will see here, that is, the coin on which I apply the more force, that will move very fastly, means the change in its speed is more as compared to the second coin. Now to understand the second factor, that is which is associated with the force, that is mass, I have considered two objects. One is of less mass, and second one is of more mass. Now what we are supposed to do here, we have to apply the same force on these two. So this is the first object, I have applied the force. Now same force I have to apply it on the second object. So when I apply the same force on these two objects which are having the different mass, then you have seen that is the small object will cover a large distance as compared to the larger one. So with the help of these two activities, it is clear to you all that is the two factors associated with magnitude of force are change in speed and its mass. What happens if we will apply the same force on two bodies having same mass? Then the body will cover the same distance and there will be a same change in their speed. But it happens when same force is applied on the two bodies having the same mass. Now the next topic which we are going to discuss, that is about the spring balance. Now by the name of spring balance of why this device is having the name spring balance, because in this device there is a spring is inserted. That's why the name of this device is spring balance. Now what is the use of this device? This device is actually used to measure the force acting on an object. We are having so many other methods to find out the force acting on an object, but it is one of the simplest or the simple device which can be used to measure the force acting on an object. Now what are the different parts of this device? First, we are having this upper portion, we are having a ring. A ring is used to hang this device or to hold this device. Secondly, we are having this scale, like you are having the reading on your normal scale. Similarly, there is one scale on which some readings are written. So this scale is known as a graduated scale. Here down we are having a hook which is used to hang the object. Here we can hang the objects on which we are supposed to be find the magnitude of force. And how we can find, that is, what is the reading or what is the force acting on the object. There is a pointer which helps to find the magnitude of force acting on the object which is hanged over this hook. Now spring balance, I have already told you, that is, there is one spring which is inserted in this device. So like here behind this device, this is the front side of this device, and the back side we are having a spring. And you know that whenever we will stretch the string, whenever we will pull the spring, it's stretched. So when we hang an object, whenever we hang an object over this point, then what will happen? This spring get stretched, and when it's stretched, this pointer move, and when the pointer stops, that will give us the reading of force acting on that particular object. So by this we can measure the force acting on the object. Now students, our next topic is, that is, the force has both magnitude and a direction. Let us understand this with the help of an activity. Here I have taken a ball which is at rest. Now when I apply the force, means we are applying some magnitude of force, then this ball moves. But I can also change the direction of motion of this ball. Okay, so this force is having both magnitude as well as direction. And students, the quantities which are having both magnitude and direction, these type of quantities are known as the vector quantities. So force is a vector quantity because it is having both magnitude as well as direction. That is, if we increase the amount of force applied, the change in the speed of object changes, and if we change the direction of force applied, then there is change in the direction of motion of the object. So that's why the force is a vector quantity. Actually, we will distribute the different quantities, like we are having mass, time, force, acceleration, distance is there, so many other quantities. We group them into two categories. One is scalar quantities and second one is vector quantities. Now what is the difference between these two quantities? Now scalar quantities are only those quantities which are having only magnitude, means those who are having only the numerical value. For example, we are having mass. mass is either it is 5 kg, it is 10 kg, but we never specify any direction with the mass. Then we are having time, we will say it's 11 a.m., it's 12 a.m., but we never define any direction with the time. So here the mass and time is having only the magnitude, that's why it is a scalar quantity. But second is vector quantities, the quantities having both magnitude and direction, like we are having force, we are having acceleration, and there are so many other quantities which we will study in the higher classes. Students, now the last topic of discussion is that is force is not always in the direction of motion of the object. Like this is the object, and we are applying the force in this direction, and the object moves in this direction. Okay, and but the force may be perpendicular to the direction of motion. That is object is moving in this direction, but the force is acting in this direction. Now what is the angle between these two? It is 90 degree. So this is the direction of motion and it is the force acting. So the angle between these two is 90 degree. So force may act on an object in the perpendicular direction. Okay, perpendicular means when the force makes an angle of 90 degree with the direction of motion. In this case, the force doesn't change the speed of object, but it can change the direction of motion of the object. For this, we are having a simple example, that is when an object is in circular motion. So when an object moves in a circular path, then if the radius of that circular path remains same, then you can see that is force. Whenever we move in a circle, the force is always act in the inward direction, towards the inward of that circular motion, circular path. Okay, so and this 90 degree angle line which I have made here, draw here, it makes an angle of 90 degree with the force. Now what this line represents? It represents the direction of motion. Now we are moving in the circle, so after some time we are at here. Again I have drawn a line which represents the force, and this line which represents the direction of motion. So here again the angle is 90 degree, that is force and the direction of motion are perpendicular to each other. So you can see in this circle, to move in a circle of particular radius, the speed of the object remains same, but here you can see that the direction of the object continuously changes. So whenever a force is act in a perpendicular direction, it doesn't change speed, but it can change the direction of motion of the object. So that's all for today. I hope you like it.